And and I would, Jim said, actually George and I don't have all the answers. The nice thing is there are a lot of resources in the company that we can usually find somebody that does know the answer if we don't. And so between the maintenance guys and the folks in the parts department, we've got some resources to answer questions. And so what I'm going to try and do today is really talk about right versus wrong in making a brick and explain why we do certain things the way we do and what we're trying to accomplish. And does everybody work around the mill room here then? I would imagine working in manufacturing, maintenance? Yeah, okay. So this ought to be pretty this should be relative to about everybody that we've got here. So let's see here.
Hey Robert, Texas Clay guys just got here.
Yeah.
We just started, guys, literally 30
I'll let
seconds
you.
ago. Can you just go around the room and you guys tell us who you are and what you do? I know Robert, you were just...
Yeah, no, that's great. That's a great idea, and we should have done. Should do that. Yeah.
Let's go ahead. I'm Jim Kruger. I'm the RPS manager here at the lab. Start.
Ross Taylor, technical director, actually.
Okay.
Drew Simpson, I want to say utility man, with everything burning, car repair,
Okay.
loading.
Cool. Hang on, we just got Come on in, guys.
Come
I thought it was 8:30, I'm sorry.
Get a name tag.
Hey, we got 3 seats over here and some pins. And
That's the bad thing about being late. You got to sit on the front row.
Very good, guys. We're just getting started anyway.
Sorry for taking up the pledge.
Oh no, we're fine. Good morning. How you doing?
All right.
Morning.
Hey, good morning. Hey, good morning.
You guys brought your hard hat. You're ready to go. All right.
You've been working this morning. That's what that means, huh?
Yes, sir.
We just got started, guys.
Yeah, you hadn't missed
Just
anything.
Literally.
Good timing.
Excellent. We were just going around the room, announcing ourselves. Start with it.
My name is Drew Simpson, and I was doing utility, loading, burning, still car repair, pretty much wherever I need.
Okay. Wash truck left, right?
Well, I always keep it washed
Regularly washed off by bank. Randy Gann, plug mill operator, Wheeler plant. Matt Dowden, Wheeler plant, production manager.
Humberto Rangel, and machine operator, Oklahoma.
Oklahoma City. Okay.
Thorough Barbie, quality control from the city plant.
Renell Johnson, Oklahoma City plant, packaging, shipping, maintenance supervisor.
Oklahoma's oven plant, production supervisor.
Eric Faulkner, Denton plant, actually in the burning department.
Are you? Well, you need to know about extrusion.
Ramon Villanueva, Texas State, manufacturing plugging operator. Dale Grissom, Texas Clay, plugging operator.
Mark Elwood, Dan plant, machine operator, manufacturer.
George Winter, Texas Clay, jack of all trades.
Rick Smith, Fort Smith plant, manufacturing burning supervisor.
Plant, utility,
Darren Fine, Washington plant, sales coordinator, and production supervisor.
This is Rio, Bennett plant, production supervisor.
George Garcia, Bennett plant, QC.
Russ Kelly, Bennett plant, manufacturing and prep, supervisor.
Very good. Thank you guys. Thank you guys for coming, and with that, I'll turn it back over to Robert.
Okay, great. No, well, good to have everybody. And actually, it sounds like we've got a pretty good cross section of folks. So, but this will be good to know whether or not you're running a brick machine every day or not. Like I said, our goal is hopefully we can talk about something that you don't know. So, just briefly about Steel. So, Steel's been in business since 1889. We're located in Statesville, North Carolina, but we've also we've got about 130 people. We run our own foundry. We run our own shop. About 90% of what goes into our machines we make ourselves. So it's kind of a neat operation for a small company. And we've also been fortunate enough, I think we've exported equipment since 1903. And so there's certain places in the world that's been good markets for us, and I'm going to explain why. But we've got, I would imagine 90% of the brick that are made in the U.S. are made on steel machines. That's pretty much true in Australia, and it's pretty much true in South Africa as well, and we'll talk about why. Steel builds machinery, and we make some grinding equipment, but probably best known for making brick machines, so plug sealers and extruders that you're running. A few years ago, well, gosh, I guess it's been 15 or 16 years ago, Steel bought a controlling interest in Hanla. And if there's anybody, it's the San Felipe plant that runs a Hanla extruder, but that's also a wet preparation process back in the clay preparation. Wet preparation meaning that you don't have screens. That material's so wet to begin with, it isn't really practical to screen it to get it down to size. And so you see a lot of that in Europe, and that's what Hanla does. And so really that machinery was well matched to that material that San Felipe that you run at the San Felipe plant. But those two, Steel and Hanla, make some complementary lines of machinery. And then Direxa is part of the company, and Direxa used to be the Saric Group here in the U.S., but that gives us the ability, if somebody wanted a turnkey plant, we can do all of that rather than just supplying the machinery. And so in a couple, I mentioned Australia later. So let's go to the next slide. All right, so now then, what are we doing? Really what steel is known for is stiff extrusion, okay? And let's talk about what that means. That really what we want to do is we want to extrude a unit stiff enough such that it's got green strength so we can set those brick directly on a kiln car, okay? And I want you to know the difference. So here's what it is. Most of the plants in the U.S. and Australia are made to where you extrude a brick and you extrude it with stiff enough to where those units are strong enough you can set it directly on a kiln car, and you don't have to touch those brick again until they come out of the kiln and you're ready to package them, okay? Now then, let's talk about the other side of that, if when we were talking about Sealy or the San Felipe plant, we're extruding we're extruding softer, okay? So you got more water in the body, and so those brick are going onto rack cars and they're going into rack dryers. And so they're not strong enough when you extrude them to be able to set them directly on a kiln car. So what we do is you don't stack them, you dry those brick first, you get them dry, then you bring them back out, you handle them a second time, and then you stack them on a kiln car. So our philosophy has always been, and it's really been adopted by American brick manufacturers and Australian brick manufacturers, that if the material will let you do it, stiff extrusion is the most efficient way to make a brick. And we make a machine strong enough to let you do that. So you've got to have power behind the machine and to be able to do that. So this picture is a good illustration. So this guy is about my size. That's from a customer in Saudi Arabia, and you can see the unit that they're running. They're running a hollow block. But that's how strong that block is right off of the extruder. It's strong enough to be able to hold him up. And so let me tell you, as an extruder operator, in some ways you're operating a fine line. That really what we want to do is, all right, so we want to keep that brick stiff enough, right, so it holds up on that kiln car and we're not cracking that bottom course. All right, so we want to have it stiff enough. But on the other end, what you're not wanting to do is get it so stiff in the brick machine that you're overamping the machine and locking everything up, right? So there's a happy medium there in running a brick machine. You don't want to be too soft, but at the same time, you got to watch how stiff you are getting it. And so the extruder operator, kind of what he's trying to do is make sure that right amount of water is getting into that brick mix. And we're going to talk about that process to how to do it. But that's fundamentally what we're wanting to do at the extruder. And we're going to be talking about different aspects of that through the rest of the morning. All right, this is simple. And I always think three things I want you to think about in the manufacturing process, because I really think you need all three. One, you need the right machinery. All right, if you don't have the right machinery, you're going to have problems from the beginning. But the second thing is you really need well-trained supervisors and operators. That if you've got folks that don't really know how to use what they've got, then that's a problem too. I had an email from one of my guys last night. We've been working with a customer in another part of the country to solve a problem, and they have variable frequency drives on their extruder, and nobody in the plant knew how to use them. And so they had the right tools, just didn't have anybody there that really knew how to operate them. We'll talk about that later this morning too. And then the last thing is adequate process control. You've got to be able to control your process, and a lot of what we're going to talk about this morning is eliminating variables, right? If we can take variables out of the process, then there are fewer and fewer things that we have to worry about. And so that's kind of the way we're going to approach this. And I think on the next slide I've got an outline. Yeah. So this is roughly what we're going to go through this morning. I don't know about you. I'm typically good for about an hour or so of seat time. So we'll get to a point here, and I'll try and we'll take a quick break, just 10 minutes to get up and stretch, but we'll go about an hour into this, take a break and stretch, then we'll come back in and kind of see if we can do the rest of the morning. But I won't read through all of those, but we're really going to step through each one of those. Probably on the front end, we're going to talk, we'll cover less, and then as we get into the back end of the presentation, we'll spend more time, because it's things that you can impact in the plant and the things that you can impact in running a brick machine. But there's our basic outline. Okay? All right, so this one, we're going to talk just a little bit about raw material. You know how a brick plant works, right? The guys in the mill room say, well, if the raw material's not right, I can't do anything with it. And the kiln supervisor says, well, if you didn't make them right, I can't do anything with them. So it takes everybody doing their job, right? So everything really needs to work throughout the whole process. And if you look at that graphic up in the left-hand corner, really what that is brick makers typically talk about sand, silt, and clay. Okay, and that is so you've got three different sizes of sand there: fine, medium, and coarse. But you've got what represents a silt particle, and you see that tiny little dot next to clay. Those are the relative sizes of what would be sand, silt, and clay. So the sand's the big particles, the silt's kind of the middle-sized particles, and clay is the tiny particles. And Clemson does a lot of research, and they do classes similar to this, and I'll tell you what Clemson says. The folks down there say, as a general rule of thumb, you need a third sand, a third silt, and a third clay. And that's a general rule of thumb. You don't have to have exactly a third of clay. Raw materials are going to vary a little bit. I think we were in a plant yesterday, and they said they were running, I think, about 21% clay. And some plants might run twice that. But if you look, this diagram is where you can actually put all three of those on a diagram. And I know there's been at least one company that figured out where they needed to be on that chart to be able to make a good brick, and they try and manage their raw materials. I think Jim's going to talk about the lab later this morning, and these are some of the things that they would pay attention to here when you're putting up a stockpile and looking at raw materials. They vary wherever you are, but here's the point that I want you to take away. We are interested in packing particles, okay? And here's the one that you can take away. If we've got all tennis balls, and we're trying to pack them together, it's only going to be so tight. You're going to have voids in between those. But if we've got tennis balls and we've got marbles and we've got BBs, we're going to be able to pack all that in pretty tight. And that's the way it works with a good raw material. You want all of those. Tennis balls, marbles, and BBs, we need them all. And those little clay particles are particularly important because they make everything slide. And so anyway, you got to have it all. We won't talk anymore. We could probably talk a day about raw material, but take that one away. Sand, silt, and clay, roughly a third. You need all of them. Okay. I dropped this one in because sometimes I'll include this one, sometimes I won't. Let's talk about a simple, just dry preparation circuit. You remember I mentioned earlier, you've got dry preparation and you've got wet preparation. Dry preparation is really, when we talk about that, is we are screening raw material, okay? And so what passes through the screens is what we're going to use to make a brick, all right? And whereas, I'm going to go back to Sealy again, it's nice that you got Sealy. In Sealy, you've got a smooth roll crusher, and the gap between those two rolls determines the size of the clay that's going to eventually go to the brick machine that you're going to use. So it's just done a little bit different. Where you've got a typically dry raw material, screening the material makes sense, and in 90+% of brick plants, that's in the U.S., that's what you're going to see. All right, so let's say we go through the primary crusher. A lot of times you've got a scalping screen to where we're going to pull out some fine material up front. What doesn't pass through the finish screen would go through a secondary grinder, and that may be a hammer mill or an impactor. All right, and I know we've got a hammer mill over here across the street at the Denton plant. Goes across the screen bank, and then what doesn't pass through the screens comes back around and gets passed through that hammer mill or that secondary grinder a second time. And here's what I want to tell you, and especially whether it's maintenance or folks that are looking after grinding, this is a system. And a system needs to be balanced, and so everything needs to work together. And I'll tell you, here's the number one sin out of grinding rooms, and the thing, I ran a brick plant before going to work for steel, and I'll tell you one of the things I'd do different if I had it do over, is I'd really look at this oversized material that's coming back off my screen bank and going back into my secondary grinder or my hammer mill again. And here's why. If you don't have adequate screens, you've got a lot of fine material in this recirculating load. And that's a bad thing for two reasons. One, it's free. You've already put the work in to grind it. All you're doing is you're not getting it out with your screens. And so I'm going to say that system's out of balance for one reason or another. But not only is that free material you've already paid for, you've already put the work into it, but when those fines come back around into that secondary grinder again, that's what really generates the wear and wears everything out inside of that on your wear parts. So not only have you already paid for it once, it's costing you money to get it out. And so if there's one thing that I would remind everybody is I would really take and I would shake those, I would take a sample off of your screen bank and see of what's not passing through those screens. Are you getting all of those fines out? And we had an engineer who used to say that it ought to be 10% or less if you're really doing a good job. And it's interesting, had a customer in South America that was questioning us, and that's exactly what was happening. The machinery was doing its job, they just didn't have an adequate screening to get those fines out of that circuit. Okay, simple point. Now let's roll on and we'll start talking about making a brick machine. All right, so just in summary, so we've talked about a consistent particle size distribution, and then we talked about sand, silt, and clay. We need all of those. And then the last one is a consistent moisture content. Now then, here's the way I look at it. I know a lot of what goes on here is evaluating raw materials and quality control and putting up a stockpile. And when you're stockpiling raw material, and Jim could add to this, but I think you're trying to do two things. We really would like that raw material to be consistent. So we're putting it down in layers. You're cutting up through it with a front end loader or an excavator. So we should get a consistent blend. But the second thing that we're doing is really what we want to do is you should be putting those stockpiles up when it's really dry. All right? And so what we don't want to be doing is when it gets wet in the winter is having to fool around with wet material, and that's the way we can kind of ensure having something we can work with. And what we'd really like to have is a relatively consistent moisture content going to the brick machine. And I think an operator can deal with some process variation, but what we don't want it to do is we don't want it to yo-yo up and down. We can handle subtle changes and we can respond to those. But if you've got wild variations, then it's going to be a lot harder for an operator to really maintain that consistent extruded moisture content. Okay. Now then, consistent raw material and additive feed. And what did somebody say one time? Said that if you really want something done, you've got to make it easy. And I thought this was a pretty good illustration. It's really simple. but I use this as an illustration that before I got to the plant in Bessemer, we ran out of our grinding room and we ran into four clay tanks. And at one time, if you wanted to change the feed rate out of the tanks, you had to kind of trot down the hill and you had to crank a hand gate open or crank it closed and go back up and see if you got it back right. And plant manager before I got there, they put little rheostats and variable speed drives on there to speed up and slow down the belts pulling out of those tanks, and made it really simple to be able to control the raw material. But regardless, how about this? Here's what I want you to know about a brick machine. What goes in is going to come out. All right, you don't really accumulate. It doesn't really get stored anywhere. What goes in is going to come out, or it's going to get stuck in the middle and you're going to be down for a big part of the day, and we don't want that to happen. And so you've got to be able to control the amount of material going into that machine. We want it to be consistent and controllable for the operator. The second thing that I'm going to remind you of is if you are putting in an additive. Okay, does anybody use additive A? Does that ring a bell? Okay, so if you plants are using additive A, and that could even be if you're running an admix body. You could be putting manganese into a body. I know here at Denton, and maybe at Elgin too, you're making some commercial brick. Well, let's think about that. We really ought to be putting that, whatever it is, we are putting that in some relation to the amount of clay running through that body. All right, and or the amount of clay running through that brick machine. So if you're pumping in additive A, and you go to a product change to where maybe if you go from a king size, I don't know, anybody run modulars out here? So you do run, king size may run different from modulars, and Western Kings may run different from a utility. But if that extrusion rate changes, you need to go back and look at those additive addition rates and really make those put those additives in proportion to the material running through that brick machine. Now then, some plants have got controls to where you can do that automatically now, but it's simple enough. If it's additive A, you can take and run it into a 5-gallon into a gallon container and see how long it takes. You can speed up and slow down that pump, but I think I want you to remember that really I figured out that it was like you should be putting those things in proportion to the really what I would even contend would be the dry weight of material going into that brick machine. And so if you're changing your extrusion rate for whatever reason, you really ought to be thinking about those additives as well, and you need some way to control them. And so a little additive feeder, you can speed up and slow down those things. But where you would be making a mistake is going from one product to another, or that extrusion rate changes, and you don't think about going back and checking these things as well. Okay? Let's go to the... Yes, sir.
Our QC guy, he's the one that adjusts the additive A to it.
Yeah.
And he goes by the amount of cut that we get. If our cut rate is down, he'll adjust it accordingly. Or if it goes up, he'll do it the same way.
Well, and that's a good point, and let's talk about that. And the cut rate should be okay. The cut rate should be okay if you're always running the same size product. All right, because cut rate is really indicative of what's coming out of that, what's going in and what's coming out of the machine. So I would say if you're always running the same size product, going off the cut rate should be okay. But I would also say that if you're running 12 cuts a minute on a utility and you're running 12 cuts a minute on a modular brick, well, that's two different amounts of clay going through that brick machine. And so it's not necessarily the same in that regard. So I think he's pretty close, but I think you got to be careful to always think 12 cuts a minute on one size brick might not be the same as 12 cuts a minute on a different size.
We have a line that runs the modular, whereas the line that I'm used to running or working with
Okay.
is just commercial.
Okay.
Okay, and it's you know, different sizes and everything, and different caps on it, which causes the, you know, how many cuts per minute you get.
Right.
So he'll adjust it accordingly.
Okay. Okay. And so I think it's good that he's checking it, but I would also think really what it ought to tie back into is really that, again, really that dry feed rate going into the brick machine is going to be more accurate. But he's using cut rate as kind of a surrogate measure to figure out what's coming through. But I'm glad you shared that, and that's how they do it. Okay. All right, good. All right, let's talk about water addition. Okay. And this is kind of a sketch out of our recommended way to add water to a brick machine. And by the way, we've got these. If you ever want to check what you're doing, we can send these out. It doesn't cost a thing. And so let's go back, and I want to explain how this works. So let's start with a water tank. All right. So you've got this water tank that's constantly being filled. You've got a water pump here. Water pump pumps water up, and overflow is going to come right back into the tank again. All right. And we're showing 2 air-actuated valves. All right. And so let's say that clutch is disengaged on the brick machine. This valve's closed. This one's open. So everything's just circulating back around. What we're also showing in here is a flow meter and a flow control valve. And there are lots of different ways to do this now. But really what this would do is, if you've got a flow meter and a flow control valve, an operator can say, I want to put in 10 gallons a minute. And that flow control valve will float in there until it dials in and lets you have exactly 10 gallons a minute. And so the nice thing is you've got a relatively precise measure about how much water is going into the brick machine. Now then, you don't necessarily have to do that. All right, but let's talk about this. Once you engage the clutch on the brick machine, this valve is going to close, this valve is going to open, and so all your water is going to be flowing into the water shroud on the back of the machine. But let's go back here for a second. Why do we want to have a water tank? True story, and I talked about learning things from customers and customers having problems. There was a brick plant in Atlanta, Georgia, and probably just like y'all, they'd start up at 6 o'clock in the morning. They'd get everything lined out and start setting brick, and it was not unusual that by 7 o'clock in the morning they'd either run the amps up and had sheared a pin on the front of the brick machine, or had packed material into a die and were having to dig it out. Plant manager's thinking, well, he's going to get coffee and he isn't paying attention to what he's doing, a brick machine operator. But that wasn't the case. You know what was happening? That plant was actually tied on to the city water supply in Atlanta. All right? And so between 6:30 and 7 o'clock in the morning, half of Atlanta is getting up and taking a shower and flushing the toilet. And the water pressure that he had at 6 o'clock in the morning was different by what he had 45 minutes later. So why do we like to have these water tanks in? What that does is that takes you off of variations in city water pressure. And I'm going to tell you, it's funny how many times that comes up when folks get away from doing something like this. You wind up having some issues. And remember, we talked about from the beginning, what we want to do is eliminate variables. Well, that's what we're doing here. We're eliminating water pressure as a variable. It ought to be set, water pressure in that line ought to be set between that pump and that bypass valve and then the spray nozzles that we've got on the brick machine. Okay, so now then, here's the other one. It's always nice to measure what you're doing. And let's go back on the other side. You see that pressure gauge right there? Now, not everybody really uses that, but I'm going to give you a number. I'm going to give you a number where we would like to see the water pressure in that line going to those spray nozzles is 40 psi. Okay? And why 40 psi? All right, now let's think about what we're doing. We're trying in a short amount of time, we really want to get a water particle in contact with a clay particle, and we'd like to do that job consistently. That's what we're doing in the pug mill, mixing water and clay together and getting those two in contact with each other. Well, we want to do the best job we can in that limited time between that material falling into the back of that pug sealer and the time that it comes out front. All right, so one of the ways we can do that is if we're running 40 psi, we get a good atomized spray back there, so you get fine little water droplets. A lot of times, it's funny, I just go in a lot of brick plants and it looks like a little boy's peeing in the back of the tub. And I'm just going to tell you, well, it may work, but that's not near as good. That's not near as good if you've got a good atomized spray, a good fine spray mist, and if you can keep 40 psi back here, then you can do it. Well, how do I do that? All right. Well, I might need to put in X amount of water. Maybe that's 6 gallons a minute. Maybe that's 14 gallons a minute. But what you can really do is change the spray nozzles in that water shroud. All right, and so we've got half gallon, 1 gallon, 2 gallon, 4 gallon, 7 gallon a minute nozzles, and typically there are 8 of these valves back here. You've got a lot of control. And let's just say you get it set up and then it gets wet and I don't need to put in much water. As an operator, you can come back here, and what you should be able to do is cut off a couple of these and still put in the water you need, but keep that good atomized spray. And so it's funny, my brother, he was the first one. He always said, read the book, you know, and so that's what the book says, 40 psi. It may be hard to do it in practice, but that would be something to strive to, is see if you can run that and get a 40 psi as a back pressure on those spray nozzles with that water entering the water shroud. Let's see. I may have this in another slide, but I see it here, so I'm going to go ahead and mention it. There's a little piece of angle iron back here at the back, and there's a reason that angle iron's back there, and for all the maintenance men, that what we're trying to do is we're trying to keep water off of that back seal. And so that's a grease purge seal. So when we grease it, we're purging grease into the tub, but what we're trying to do is keep dirt out. And that little piece of angle iron back there is trying to keep dirt off of that rear seal. If you ever go into a brick plant and it looks like a little mud volcano at the back of a pug tub, that's what's happened. You've either lost that rear seal or you hadn't been greasing it, and that water and mud's kind of working its way out of that back seal on the back of that tub. A lot of times the maintenance guys think, God, that just makes it hard for me to change that rear knife, which, by the way, is one that's going to wear probably faster than some others. And we're going to talk about the job of that rear knife in a little bit, but there's a reason that little piece of angle iron's in there. And a lot of times you'll see them cut out, but it is trying to keep dirt and water off of that rear seal. George, before you advance that, does anyone, I can't remember if any of the Acme plants, do you have any of the plants have pug masters or an automatic water control systems? Okay, and it might be good, let's talk about that for a second. Let's talk about those for a second. So how about this one? So this is kind of a middle of the road system in a way. All it's doing is telling an operator, if you've got a flow control valve and a flow meter, it is telling the operator exactly how many gallons a minute he's putting in. But he's got to figure out how many gallons an hour is right, and is my raw material changing, and how does all of that work? The really nice systems today are automatic moisture control systems. And how they work is you've got two things on the feed belt coming up to the brick machine. You've got a moisture transmitter, all right, which is reading the moisture content of the raw material, and then you've got a belt scale. And the way those systems work is they actually do a calculation, and they'll do a calculation. So with a set point, they'll kind of figure out, it's like, well, I know this is my moisture content and my dry feed rate. They'll automatically control this valve to add the right amount of water at the right time that material's falling in the back of the pug sealer. And if everything works, the goal is let's just say I want to extrude a clay column at 17.5% moisture. You can set the system at 17.5, and even if the incoming moisture content varies a little bit, the dry weight varies a little bit, that system automatically controls the water addition and should do that automatically. And some folks have them and love them and run them in nothing but automatic. We'll go in some plants and they say, you know what, I just don't trust it, and we've never been able to really get it to control right. But I will say that is a different level of control. They're not always cheap. I don't think anybody says that they are, but it is a different level of control in what you're doing. For years and years, a good brick machine operator could keep a feel on where his moisture content was and knowing when to add water or when to make adjustments and how much. And I will tell you this, I think running a brick machine is a lot like steering a big ship. It doesn't turn on a dime. You know, so the good ones are really, and you run a brick machine, is that true?
That's true.
That you really need to be subtle in your adjustments. A lot of times people will get up there and panic, and you'll dump in a lot of water or cut it off because you watch something happening, and then you're going to create a problem for yourself. And so a good operator develops a feel. Yeah.
I'm first doing it, I'm one of those, I panic.
Okay.
Just the water, and next thing you know, it's like, put too much water, cut it back. And the clay comes out, the brick comes out like mud.
Yeah. And well, and I will say this, and it's true for a lot of things. There's no substitute for experience. But I would say having experience and getting accustomed to seeing things and what to look for. But I also say paying attention to what you're doing. You know that if you, it's what is it? They say never turn your back on a kindergarten class, never turn your back on a brick machine either, right? Because it can get away from you in a hurry. But anyway, we'll leave it at that. Let's go to the next slide and see what we got on there. Okay, so all right. So I did have one in there to where we talked about that spray shield in the back. We typically, when we build a new machine, we've got a piece of skirt rubber on the front side of that water shroud. And so we talked about that atomized spray mist, and we want to keep that. We don't want that floating across the plant. We'd like to keep it contained. So there's a piece of skirt rubber. A lot of times you go in a brick plant and that's missing. You don't see that. It's a small thing, but let's talk about right from wrong. So you see that material falling in and falling into the back of the pug sealer, and it's going to create a sheet. And it's a small little thing, but we always, when we're setting up a new machine, we want to know which direction the material is going to be coming in, because we want to set it up for those spray nozzles to be hitting each side of the sheet, the big flat side of the sheet, not the skinny piece. And again, so we can kind of maximize contact between the clay and the clay and the water particles. Every now and then you'll see folks move a brick machine or move a water shroud from one machine to another, and that's not right, but that's the way it ought to be, the way it's shown in the diagram here. Now then, I think I've got another slide. We're going to talk about the optimal level of material in a pug tub. And George, let's go to the next.
Let me ask a question, Robert.
Yeah.
Some people have their clay feet coming in from the back.
Yep.
I know some plants do. I don't know how many.
Okay.
If you do have it coming in from the back, do you put the spray nozzles on the other sides of the...
That's right. So if it's coming over to the gearbox into the brick machine from the back, then you ought to have spray nozzles on the back and the front. Okay. Is the way that really should be built. And we've got a checklist in the shop, and that's one of the things we want to check when we're building one. Is we always want to know where that material's coming in, and that's a good question.
Okay, you're saying, okay, the kill comes in, and one is dropping into the plug, okay, and then it's coming this way.
Uh-huh.
The vacuum, which is dropped to the extrusion.
Right.
The water that I've seen is right here. Okay, it comes in, and the water spray is right here, and then it comes forward. Is there supposed to be one on the back side of that as well?
Well, how about this? So what we've really got is there's a box on the back, and I think it's about 3 feet long. Isn't that right, George? But you've got a box in the back, and typically what we're wanting to do is add all of that water at the back of the pug mill or the pug sealer, and then give it time. Let the knives and everything do its work to really pug that material or work that water and clay together. before it gets to the sealant auger. I will say, let me tell you something that again, learning things from seeing people doing good things, and the one thing that I did like is one of the brick plants has got, so we talked about this is the way it should work. All right, now we talked about getting in trouble or worried about it getting too dry on you and your amps going up. I saw one brick plant where they had literally a foot valve, and they had a spray bar across the length of the tub. All right, so running front to back. And so if the amps started going up, rather than taking a hose and wetting it down, that they had a spray bar that ran the length of the tub, and he could hit that foot valve, and you'd automatically get water dumped across the length of the tub. And I thought that was a really effective kind of emergency water addition in a way. That was pretty nice. And so I trust you guys as operators to tell me whether that'd be good or bad. Normally what we want to do is let's get the water in early and let's let it work in. But when you're trying to keep material from getting too dry before it gets down to the extruder, I thought that was a pretty good way to get it put it in. Yeah.
To the atomized thing, what kind of problems do you see when they don't have it atomized properly? They're not water infected.
Well, and how about this? You run the risk of just not having that. You could have something. You could have some clay particles really wet where others are still dry, and we're just making it harder on the motion of that material in the pug tub and through the sealant auger to do that mixing job. That's what it would be.
So how would that show in the finalized product? You know? Would that start creating weird cracking?
I don't know that it would. I don't know that it would. And it would be a hard one to diagnose. Yeah. And how about this? I will say this. I'm going to go. Let me go to an extreme. That if you're making tile, if you've got a dry particle in a floor tile or a roof tile, it'll create a flaw in it. Now, making a face brick are typically a little bit more forgiving, but that's what you can have happen. And I'll say that they're more sensitive to those little dry particles when you're making something like a tile than necessarily a brick. But it might be hard to look back and say, okay, well that's a crack or that's a flaw because I really I didn't get my water mixed in as well as I should. It's going to be hard for me to tell you that you can really pick up a defect from that.
You had some kind of noticing of what kind of problems they were running into when they want water.
Yeah, and I'll say there's probably going to be other things that are contributing defects more than that. Yeah. But if we want to try and do it right, that's what we really want to try and do. Okay. And how about this? Let me mention something else. So I said to read the book, and so here's the practical side too. If you have to start using those tiny little spray nozzles, and so I mentioned down to a half a gallon, well, those little orifices or the holes in those spray nozzles get awful small. And so if you get any trash in your water supply or anything, you can plug those little nozzles up quicker. And so when you get into the bigger ones like 4 gallons a minute or 2, 4 or 7, that's not as much of an issue. But if you get any kind of little trash in your water, you can clog those up as well. So I'll just tell you, there's the flip side of it. But we would like a good atomized spray. Okay. All right, we're going to come back. Let's talk about scrap return, and this is a little tricky. And let me tell you what we like to see and like to do with scrap return. And so I give this example. So a lot of folks that, let's just say you don't have you have scrap coming off of the setting machine or scrap circulating back around. And if you don't have a scrap return feeder, here's what happens. And let's see if we can use some simple numbers. See if you can follow me on this. All right, so let's just say that we've got 50 tons an hour coming out of the front of the brick machine and everybody's happy. And maybe we're trimming off some waste there. We may be doing a wire cut and we've got the ends of the slug that are coming back around. And let's call that 5 tons an hour. So 45 tons an hour are going on the brick machine and 5 tons an hour are circulating back around. and I've got 45 tons an hour coming up from my ground clay storage. All right, so 5 tons recirculating, 45 tons coming up from the brick machine, which is the same thing that's going onto the kiln car. So everything's balanced and everybody's happy, right? Then I get a rock hung in a wire, and I've got 6 slugs on the belt before we realize it. The guys down at the setting machine wave their hand and flag it, and so I walk down and I take my screwdriver and I get it out. All right, so now I've got 6 slugs on the belt. We're good brick makers. They're not going on the kiln car, so we're going to run them back around. Okay? So now then, what's happening? If I don't make any other adjustments, now then, rather than having 5 tons an hour coming back around, for a short window, I've got 50 tons an hour of material coming back around on my return belt, and I've got 45 tons an hour coming up from the mill room. So now then, rather than having just 50 tons an hour flowing through that brick machine, I've got about 95. And what did we say about brick machines and pug sealers? They are not going to accumulate material, right? It's going to go somewhere. And so if you're not paying attention to what you're doing, if you're not an experienced operator, what's going to happen is that material is going to build up in the vacuum chamber, and it's going to pack in, and I'm going to be sitting there with a hoe trying to dig that stuff out for a couple hours, right? Has anybody had to do that? Okay, well that's good. So that's what you don't want to have happen, all right? And again, happy medians, and how do we want to do that? So let me tell you, here's what's nice for and let me tell you, let's go back. So I talked about the plant that I managed before coming to steel. Guy that ran our brick machine had been up there 15 years, and he knew exactly when to cut off it. When he had a big recirculating load, he knew exactly when to cut off his fresh clay feed, let that material work down, and then bring everything back up again. He was really good at being able to manage that. Let me tell you what makes it easier on an operator, and what we really think is the right way to do that is to use a scrap return feeder. And so what happens is all your scrap would run into that feeder, and you've got a hopper on top of it that's got enough storage capacity that it would store that 50 tons of material for that short little window, and then it runs and it chops up that scrap and slowly meters it back out at a consistent rate. And so it takes that variable out of an operator having to know when to cut off his feed and when not to. But that's a nice tool to have, and so you can kind of ease it back in and control it. And I will say this, I don't know if you've got any experience, sometimes material behaves differently. After it's passed through a brick machine once, sometimes it's got more plasticity to it and behaves differently, and you guys would know for your individual plants. But again, we think from a philosophical and principle basis, it would be better to have a scrap return feeder which lets you meter that scrap back in. I think I've got a slide in here. That's what we call an even feeder. And so you've got a live bottom, it's a live bottom feeder, which means you've got rotating shafts in the bottom. There's a cross shaft up in the front to chop up those brick bats or those pieces of slugs going back in it and just meter those back in. This one's even got a retractable floor in it. And so some plants that are making a commercial or architectural brick, like those, because you can clean everything out, pull the floor back and clean everything out when you're done. But again, controlling scrap. All right, let's go to the next one, George. Okay, now then, we're working our way through. And so this is a good graphic, and one of those things I would like you to remember today, if you don't remember anything else, there is a correct level in the pug sealer, all right? And what we would really like to see is that image shown on the left-hand side of that slide, to where when that knife swings over to about 12 o'clock, we'd like to see about 4 inches of the top of that knife when it swings over to 12 o'clock. And we'd also like to see a good consistent level in that pug tub from the front to the back. Now then, so this says that it's too low, and that's right. How about can you tell me what would be the condition that would cause this? Why would you see that?
speed at Johnson?
Okay, that's a good one. So there's not enough material coming in, right? Okay, that's good. Anybody else?
Speed not too quick.
Well, and how about this? And you're close. I'll give you partial credit for that one. That really what happens is that pug shaft, we could also say the pug shaft's turning too fast for the amount of material in it. And I want to talk about variable speed drives a little bit and what it would let you do if you had them. And so maybe we talked about making different sizes, and if you always run your pug sealer at a consistent speed, you can't really change the speed of the pug shaft, and then we've got to change the amount of material coming in the brick machine because of how fast we can set brick on a kiln car. So we may not have any choice. But now you've got more and more plants that are putting in variable speed drives, and so what it lets you do is speed up or slow down that pug shaft to where what we'd like to be able to see is that condition over on the left-hand side all the time. And what I would just tell you, if you always run like this, that's a problem. And we don't really want to see a pug tub starved like that. We talked about mixing water and clay, and we'd like to take advantage of that residence time. And when you have this much material in there, it's going to spend more time in there. There's more opportunity for that to pug that water and clay together. But I'm also going to tell you, every now and then, if you run like this, you can actually lose your vacuum seal at sealing augers. And you ever kind of hear, you can hear it. It almost sounds like a brick machine burping a little bit or something. But you can, it makes a little bit of a noise, and to me, that is a hard problem to track down because you're losing vacuum, and that impacts the quality of brick. And but if you run like this, it could come and go. And so this is not what you want to do. We want to see that over on the we want to see that image over on the left-hand side. And George, let's go to the next slide. I think I've got a shot out of a plant here. So that's actually a good-looking pug tub, and my guess that is an Acme plant. I think that picture was taken in an Acme plant. But if you look at that, there are a couple things. So you can see what it looks like as that knife is coming over at 12 o'clock. All right, and then the other thing is the level of material through that pug tub is pretty level from the back all the way up to the front. That's a good thing too, and that's what we want to see. And I love, it's interesting, single shaft pug mill, but I love walking in there, and you can literally at times see material just looking like it's just walking its way up towards the front. When you got everything right, it works, and it works well. For the maintenance guys, I don't know if you're responsible for changing pug knives or not, but let me tell you one thing. If you can't go in, a lot of times you're doing a little bit tonight and a little bit next week, but if you're changing pug knives and you're not going to change them all at the same time, what we encourage you to do is go in and change them in a row. Don't go into the back and change 12 in the back and then go to the middle section and change 12. It'll change the flow characteristics of the material in that pug tub. What we'd really like to do is change them all in a row and then go change another row, and you can avoid having that problem. But that's a good looking pug tub, and that's what we would really like to be able to see in all your plants. Okay? All right, let's talk about installing a pug knife. So this might be good for operators and the maintenance guys. And so I'll skip down. Well, let's talk about the pitch to begin with. So when we set the pitch of a pug knife in our factory, we'll use a little bit of an offset square, much like you see there. But those blades are pitched back only about 1/8 of an inch. So they are subtly pitched back. And think of it like that. Those knives are just a little bit reaching back behind, grabbing material and pulling it forward. The pitch on them is really pretty subtle when we set them in the when we set them in the factory. And George, or anybody else, I don't know what you say. We'll say they are adjustable pitch. You could put more pitch on them to impact how that material flows through the pug tub. I think it's a tough way to do it, and I'd rather keep them relatively consistent unless you've got a compelling reason to change it. But a very subtle pitch on the pug knives to begin with. The second thing that I want to talk about is when we put a pug knife in, that we should have a 1/4 inch gap between the blade and the shaft. Okay? And here's the reason for that. If you set that blade all the way down on the pug shaft and you don't have that gap, you tighten everything up, what we run the chance of doing is putting that shank in tension. And if we put that shank in tension, and by the time it cycles in that tub enough, you could break one of those shanks. And so you really want to wind up having just a little bit of a gap between the pug shaft and that blade in operation. Let's talk about, if you don't know, I'll talk about how those knives are actually held in. What's shown here is an aluminum bushing, a tapered aluminum bushing. And then what we've also got is you've got a bolt that goes in the end and a washer underneath it. And what happens is you tighten this bolt, you flare that aluminum washer, and it locks everything together. So that's the way they're held in place. Now then, I think let's go to the next slide. Let's see how my timing is here. Yeah, not too bad. So now then, there are a couple things that I'll tell you. So one, let's talk about installation. If you ever put in a have to replace a pug shank or put one in, there are a couple things I'll tell you. One, always put never sees, all right, on the shank itself, and between the shank and the aluminum bushing, put never sees on them, okay? If there is, so I work for steel, and I'm going to tell you what I think is probably the most hateful things about our machines is if you get a shank that's been in there for a while, they are not easy to get out. And honestly, even for us, we continue to kind of look at some of those, look at better ways to be able to get those out. But it can be a bad job. Let me tell you a couple things that may help you though, in addition to always using anti-seize or never seize when you're installing them and being generous doing it. So one, you remember we talked about that aluminum bushing, and that aluminum bushing locks that shank in place when it flares out. Well, when we go to take one out, the last thing we want, well, let's say we take that bolt out of the end, all right? The last thing we want to do is hit on that aluminum bushing and flare it out. What we need to do is separate that shank from the aluminum bushing. So what we've got is we do make a tool that's got a hardened punch pin that goes into that threaded hole, and then you've got a high strength steel punch that you can actually drive them with. And so we do make a shank removal tool, and it works pretty good. It does not work always. So here's one of those things. I talked about us getting better from learning from everybody running our machines, and I think this came from, I'm trying to remember which one of the Spences came up with this. If this was John. Okay, you know what I'm getting ready to say with the hole saw, right?
Yeah, I tried it. I was the one trying it.
Oh, is that right? No kidding. And it works.
Some of them.
Some of them. Okay. Well, and so here's what they came up with. We talked about, all right, so you've got a steel shank, and that's pretty hard, but that aluminum bushing's softer metal. And what they came up with doing is actually the way a hole saw works. And so you take and put an attachment on there, and you can, and in some instances, you can drill out the aluminum bushing. And if you can drill out that aluminum bushing, it'll free those shanks to come up. But that was actually, one of your plants there came up with that. I'm glad. I thought I couldn't remember who, so y'all did that then. But that's a good idea, and that isn't something that started with us. But I will say, so how about this? So the good guys are always a little lazy, right? So what you really want to do is make sure those blades stay in pretty good shape. I think we make a couple of different blades, and I guess I could put them in here. The bolt-on blades have studs in them, and they bolt directly to the blades or the shanks. And the problem with that is once those blades start to wear, you're gonna wear into the shank. All right. Most plants now have slip over blades, and those slip over blades protect those shanks. The shanks aren't exposed to the material at all, and so it should keep you from wearing those shanks. But I know pipe wrenches and things like that get into pug tubs, and you wind up breaking some stuff. So you may have to deal with it one time. But maybe I told you a few things that might be able to help you get them out. But even we struggle with that sometimes. We're doing a little used equipment now, and we even struggle with being able to get those out at times. All right. Yes, sir.
Robert, speaking of drilling out the bushings, if you're interested in seeing it, can't picture it in your mind, there's a video on YouTube.
Yeah, that's right.
It actually tells you what size of hole saw that they're using. And I've looked at it several times and showed it to people. So
that's right.
I think if you type in JC Steel Shank Removal on YouTube, you'll get the video. It's not real long, but it'll give you a good visual of what they're doing with that.
And I'd forgotten we did make a little video clip of that. Thanks for that reminder. Okay.
Yeah.
All right. So we talked about. You remember we talked about that the angle iron in the back, and that we want to keep water and dirt off of that rear seal. The knife in the back. The knife in the back of the tub is different from the rest of them. Okay. And the knife in the back has got a flat side on the back, and you pitch it differently. We want it to sweep material off of that rear bulkhead and rear seal in the back of the tub. And again, we want to purge that thing with grease, and we want to keep water and dirt away from it to keep that seal in there. And so this one from a maintenance standpoint, it's out of sight, out of mind, hard to get to, but it's probably one that you need to keep a good eye on. So if you've got maintenance schedules and all, you certainly need to kind of open up that water shroud in the back, and somebody needs to get in there and take a look at what that rear knife looks like. That one's going to wear as fast as any, and it's got an important purpose to it. Okay, we talked about the pitch of the knives in the tub, and they're pitched back at just about 1/8 of an inch. Well, that is true. That's true for all but the rear knife, which we just talked about, and the front knife. And the front knife, we really want to pitch it differently. And as shown in the diagram here, we want to pitch that front knife to where it's really in line or really feeds material into the rear wing of that sealant auger. It's going to help to funnel material into that sealant auger. And so it's going to be pitched a little bit different than the rest of these back behind it. I will also tell you it is possible to install sealant augers 180 degrees out from that knife. You should have a knife that's going to really line up to where it's going to be feeding that rear wing of the sealant auger. Every now and then you'll see some plants to where something happened as they were changing augers, and the sealant augers didn't go back in the way they came out. And you'll see these flipped over 180 degrees where you don't have kind of that front knife that's able to kind of provide a leading, feeding edge to that sealant auger. So I'll point that out as well, and just one of those little things to keep an eye on. Okay? Yes, sir.
Well, what I noticed is the plug mill, when the augers start to go out, it starts to build up in the front. The rest of the plug is, like you say, a good level.
Yeah.
When it gets to the front, it starts to build up. Could you adjust that front auger to cause it to go ahead and just keep?
I don't know that there's any adjustment on it. I don't know that there's any adjustment that you can make. And what I would just tell you, that when you start to see that material backing up around that sealant auger case, is you've got sealant augers that are probably worn out and need to be replaced. There's no real adjustment in there or any way to fix it. You've just got worn sealant augers, or likely have worn sealant augers. And we can talk about one more thing in that sealant auger case, but that's indicative of what's happening. And that's another thing that you can walk into. You can walk up on the platform on a brick machine or walk into a brick machine, And if you see that material kind of rolling back and piling up, it's time to change sealant augers is really the answer to that one. Yeah. Okay. All right, now then, so we've walked all our way up to the front of the brick machine, and so here's kind of a cross section of it. And so let's talk about what we've got. All right, so you've got a rear sealant auger, and we talked about that knife feeding it, a front sealant auger, a sealing core, and then you've got a shredder here. You've got a shredder and a sealing die. Now then, the sealing die is a wear component, but we do make those in different sizes. And what we really want to do is size those to where we kind of we kind of match those to the speed of the machine to where we are able to create a good vacuum, help to create a good vacuum seal. So the shredder in the front is we're just shredding up that clay before it falls down on the augers in the brick machine. If we didn't have the shredder in there, we'd essentially just be extruding a pipe. I want to come back to your question here in a second, but I want to mention this one. One of the things that every now and then, those little things you see people forget or have trouble with, is the way we have designed, there are actually 2 rounds of non-wearing packing that actually go behind the shredder, okay? And why do we have that packing in there? Does anybody know the answer to that? Vacuum. Good answer, good answer. Okay, so think about this. So we talked about castings, and so the sealant augers are castings, and so they're a little rough. They're made out of 28 PC, which is kind of it refers to 28% chrome. It's a high chrome alloy, so it's got really good wear characteristics, but at the same time you just about can't machine it. It's really hard, and it isn't really practical to machine it. So you've really got an as-cast part here fitting over a shaft that is machined, and it's got a fairly tight dimensions on it. But the reason we put this packing back in here, that you could actually, we're trying to draw vacuum. So what happens is we draw it, we want everything tight enough to where we form a vacuum seal. We hold vacuum through the vacuum chamber here and up to the product comes out of the front of the extruder. So if we don't have this packing in here, you can actually draw vacuum in that little crack or that little fit between the OD of the auger shaft and the ID of the sealant augers. And so by putting this packing in here and greasing it up, we seal up that void and keep from having a vacuum leak along the shaft back in here. So anyway, just as a reminder, there's a reason that packing is in there, and that's what it's intended to do.
So really, Robert, I guess I knew this, but just looking at your diagram now, the seal, the actual vacuum seal, you want that seal to be taking place right at the sealing core. I mean, that's where you hold the vacuum.
Yeah,
right there.
yeah.
You can't really count on the augers, what's back in the augers, to be making that seal. The augers are just compacting the material up to that point, and your seal is happening at the core.
That's right. I think that's right. That's right.
Recess on that front sealer constant so that you can have some packing on the shaft as well in the earlier machine?
Yeah, and I'm trying to think. That might be a little. There's a gap in here to be able to fit that packing in now. I mean, there's an obvious place to be able to put it in. Let's go. I think I've got another slide, George. Yeah. Oh, okay. So here's the other one that I'll mention. So you talked about the sealant augers and material backing up, and is there any adjustment? Probably no adjustment. But let's think about it. What's happened is we've worn those sealant augers likely to where we're getting a gap, and that pressure is such that material's wanting to backfeed rather than move forward. So that gap is one or two things. The augers are worn, or you could be wearing the sealant auger, the sealant auger case itself. And these have been around for a while, but it's always good to talk about. At one time, we just had a ductile case, all right? And so we talked a little bit about 28% chrome. So pug knives, sealant augers, your extrusion augers, your liners, a lot of times die bases, those are all made out of high chrome alloy, good wear characteristics, not easy to machine. Ductile, I can take and I can hit ductile with a sledgehammer, and I probably am not going to be able to break it. That's how strong ductile is, but it doesn't have the same good wear characteristics. So at one time we just had a ductile sealant auger case, and what we went back and did is change that to where it accepts a chrome liner. And so the liners are made to be replaced in there. And our line is this should be the last sealant auger case you ever buy. You just need to replace those liners. So not only is it lined, but those are chrome liners in there, and chrome will last a whole lot longer. So there's two things to kind of keep an eye on: is not only the sealant augers, but also is that case worn or the liners inside the case worn. It may not, but it may not be. But this is you got to think: you got a gap there. Is it sealant augers or is it the liners? It could be either one. But I would like to think, George, I don't know if you know off the top of your head, does every Acme plant have a renewable sealant auger case now?
We got one.
You do have one?
We just replaced ours last
Okay. Well, it's just something to keep in mind. If you do have a ductile case, you really ought to go to something like you ought to go to one of these, because it's a better value for the money and in the long term by far. Okay. Let's see where we are. Okay, so we talked about so there's the packing, and then then the shredder and the packing that would go back behind it. So, or a half of a shredder. And that's a chrome piece as well. Okay? Let's see, what are we up to now? Here's a good one. So this is a change that we've made, and so an aluminum vacuum chamber lid, and the old ones are made out of ductile. All right, and so good, dirty, good, sturdy. You're not going to break one, but they're heavy. And if you're having to open that lid, and we've seen some plants that have put counterweights on them to make it easier for an operator to be able to open them. But what we did is we've now got an aluminum vacuum chamber lid, and it looks different from it looks a little different from the old cast ductile lids. But these are a lot easier and a lot more user friendly. And I'm going to take an opportunity. I'll point this out. You see that hole right there? That's actually another nice little thing that we offer now, is a vacuum chamber level sensor. And so when this actually is, you insert a probe that goes up underneath the pug shaft, and the way that works is when material builds up in the vacuum chamber and gets off to it, yes, that's right, or give you an audible alarm. And so we've had some in the past that have set up on the glass, but these actually work pretty good, and I actually recommend them. And again, the point is to keep you out of trouble and keep you from having to spend that half a morning digging that vacuum chamber out. But that's what that's for. All right, but aluminum vacuum chamber lid. All right, and let's see.
Does anyone have an aluminum vacuum chamber lid?
I don't think so.
Is this real new?
It's relatively new. We've had them out for a couple years, and it's been, I'm trying to think. Seems like what happens, you'll have somebody that says, "Gee, that's great," and they'll buy them for all their plants, and then others, seems like that's made more at a plant level. But you said you guys have got one then?
year. And we have the hole in the bottom of the level.
Oh, okay. You've got a level sensor here. Okay. But we were talking about, how about this lid?
Yeah, we have
You've got one of those as well. Okay. But
It's a lot lighter.
it's lighter. Yeah. It's notably lighter. I'm just going to say
Oh my gosh.
Yeah, user friendly. And here's my knock. Here's my knock on the ductile one we made. I like the ductile one, but there's not even a lip to be able to. There's not a good lip on it to be able to get your fingers up underneath it. And so it is one of those things. Honestly, if we're looking back at our equipment and thinking it is an opportunity for somebody to get hurt, and so this is a better option. It's just lighter and easier to handle. So if you're an operator, you might like that. And so that's one thing we can do today is talk about some things that have come out.
Okay, even it's lighter, it's easier, but will it still
Seal? Oh yeah. And actually what we do is we actually machine on this one, we've actually machined a recess in it and fit up a rubber gasket up on the inside. And so it seals just fine. Yeah.
Well, the next question is, open it to clean it, will that gasket?
No, it stays in there. It stays in. Yeah. Oh, good.
That sounds like a real improvement.
Yeah, it's a good thing. It's a good thing. So it is. So, all right, George, let's see what's up. I think we might be up talking about vacuum, and we are. How about this? We are also at 9:30. We've been in here pretty close to an hour and a half. Everybody ready to stretch for a minute? How about let's do this? I've got 9:27. Let's be back at 20 till. We still got a good bit to cover, but let's be back at 20 till. So that's going to give you about 12 or 13 minutes, and stretch, take a little walk, and then we'll...
There's another restroom down the hall as well, not just this one in